back to day 2 of matrices. We are in chapter 4. Yesterday we talked about some basic introductions to matrices and what some elements are and what the pieces of them are and setting up some equal matrices. Today we're going to be looking at some operations of matrices because you can do addition, subtraction, multiplication. Technically division would just be the multiplication by a fraction. So you can divide. You cannot divide matrices, but you can divide by a constant. So we're going to be looking at some operations with matrices today and what that looks like and how to use those. So addition and subtraction of matrices. All that means is that you are adding each corresponding element. Two things to notice. One, they have to be the same dimension. You have to have a 2 by 2 and a 2 by 2 or a 2 by 3 and a 3 by 2. It can't be close, it can't be the reciprocal of one another. It has to be the exact same dimension. And also with this negative, it distributes to each element inside that second matrix. So you're going A minus E, B minus F, C minus G, and D minus H. You're setting up each of those individual addition and subtraction problems within this matrix. So this is what we could call our result or the solution matrix, and it's just the answers to adding or subtracting each of those corresponding elements. So let's try this. They want us to find A plus B. Again, capital letters refer to, that's the name of a matrix. So we have A is equal to this, B is equal to this matrix, and they just want us simply to find A plus B. So we're going to rewrite our matrices. So we're going to have 4, negative 6, 2, 3. Plus, and then we're going to have negative 3, 7, 5, and negative 9. So all I'm going to do now is add the corresponding. We have 4 plus a negative 3 is a positive 1. Negative 6 plus a 7 is again a positive 1. 2 plus 5 is 7. And 3 plus a negative 9 is a negative 6. Close out our matrix. And this is the matrix A plus B. Let's go ahead now and find A plus B for the second problem. So we look at this, we have 3, negative 7, and 4. Second row is 12, 5, and 0. And when I add those to the next matrix, notice this is a 2 by 3, and this is a 2 by 2. The dimensions do not match, so there is no solution to this problem. We cannot do this. It's undefined, no solution. However you want to word that, we cannot do a 2 by 3 adding to a 2 by 2 because there's not a second or third column here to add to this third column. So you have to have the exact same dimensions, so that one doesn't work. Alright, so here's a part C. We're going to go ahead and do this one more time with ones that actually do work. So we have A plus B, so we're going to have negative 5, 7, negative 1, and 12, plus 11, 3, negative 4, and negative 5. So again, we're adding those corresponding elements. So we have the first element and the first element. So we have negative 5 plus an 11 is 6. 7 plus 3 gives us a positive 10. Negative 1 plus a negative 4 is a negative 5. And then 12 plus a negative 5 is a positive 7. We add our brackets around the outsides of that to complete the look of the matrix, and that's our solution. Now we're going to take a look at some subtraction problems here. The subtraction problems, the key part here that you want to be very careful of is looking at that distribution of the negative there. Do not forget to use that negative on any pieces of that. So when I rewrite this, we're going to have 9, 2, -4, and 7. And then we're subtracting 3, 6, 8, and -2. So we have a 2 by 2 and a 2 by 2, so they are the same dimension, so we're good there. The other thing we want to look at now is that negative sign. We are distributing that to each piece. Sometimes what I like to do, just so I don't forget that, is I'll rewrite this. So the first one stays the same. 9, 2, -4, and 7. And I'll change that to a plus and change all of the signs in the second matrix. So just like when we're adding or subtracting those polynomials and we distribute that negative across the polynomial, so we can do the same thing here. I can make this a -3, a -6, a -8, and a +2, not a +4. So all of the signs of that are going to change in this particular problem. And now I go back to using the addition rules. So I'm just going to have a 9 plus a -3, which is a +6, 2 plus a -6, which is a -4, -4 plus a -8 is a -12, and 7 plus 2 is 9. Add your brackets, and that's your final answer. Let's take a look at part B here. Again, we have a 2 by 2 and a 2 by 2, so our dimensions are the same, so they work. So I'm going to rewrite these so that we have 12, -4, -5, and 8. I'm going to show it to you this time without doing the distribution to show you that you can do it just by subtraction. But again, do not forget to use that negative, because I see that a lot where kids forget to use that negative, and they'll just say 12 and 7 is 19, and they might forget to do the subtraction in between. So if you do it this way, just please be very, very careful with it. 12 minus 7 is a +5. -4 minus 3 is -7, because you have two negatives. -5 minus a -3 becomes -5 plus 3, which is a -2, and then 8 minus a -2 is really 8 plus 2, which becomes a +10. Again, be careful with those negatives, please, if you choose to do it this way. Scalar multiplication. Scalar multiplication is a fancy word for just meaning we're going to multiply by a constant. There's really no difference there. When you're talking about matrices, a scalar is what we call the number out front. So any number that's not in a matrix is now called a scalar. So it's just some fancy definition work that goes with that. So with the scalar, we have a constant that can be multiplied by a matrix. And so when we have scalar multiplication, all that means is you're distributing some number out front to every number on the inside of that matrix. So here you'd have A times B, A times C, A times D, and A times E. It's just the distribution property with a matrix. So here they want us to find m, or 3 times m, and this is m. So I'm going to have 3 times the matrix, 2, 8, -3, 5, -9, and 2. So looking at this, we're going to distribute that 3 to everything on the inside of the matrix. So we're going to have 3 times 2, which is 6, 3 times 8, which is 24, 3 times -3 is -9, 3 times 5 is 15, 3 times -9 is -27, and 3 times 2 is 6. And that's your result matrix. Your solution matrix is that 6, 24, negative 9, 15, negative 27, and 6. Now we can also do it with a negative. That doesn't change anything. Scalars can be both positive and negative. So this means we're taking a negative 4 times that whole matrix. And both of these matrices happen to be 2 by 3s. There's no stipulations on dimensions. You can have any big or small matrix to do scalar multiplication here. So we have negative 4 times negative 7 is a negative 28. Negative 4 times negative 4, two negatives make a positive, so it's 16. Negative 4 times 10 is a negative 40. Negative 4 times negative 2 is a positive 8. Negative 4 times 6 is a negative 24. Negative 4 times negative 9 is a positive 36. And so there, notice in both of these, the result matrix is the same size as the original matrix. None of the dimensions have changed, the size, the orientation has not changed. They are the exact same size that you started with. We can put this scalar together, the scalar multiplication together with some of the addition and subtraction things we were doing before. There are a couple of different ways you can do this, and I'll show you some of those different ways. It just depends on how you think and how your orientation works with some of these things. So they're asking us to find 5a minus 2b. The first thing you want to do is write out that 5a times or minus 2b. So we're going to have 5 times matrix A, which is this first one. So 7, 3, negative 4, negative 1. Minus 2 times b, which is 9, 6, 3, and 10. Just like the order of operations, you want to do the multiplication first. So order of operations still applies to the matrices, that doesn't change. We have to do the multiplication first. So we're going to multiply out 5 times a. So we get 35, 15, negative 20, and negative 5. Here's where you have a couple of different options. We can do negative 2 times all of these things, and then this turns into an addition problem. Or we can do a positive 2 and keep the negative out front. I usually choose the former, do the negative 2 times everything, and then turn it into an addition problem. So negative 2 times 9 is a negative 18. Negative 2 times 6 is a negative 12. Negative 2 times 3 is a negative 6. And negative 2 times 10 is a negative 20. Now we have two matrices that are both the same dimension, so we can't add these. So when we get our final answer here, we have a 2 by 2 matrix. We'll squeeze it in here underneath. 35 and negative 18 is a positive 17. 15 plus a negative 12 is a positive 3. Negative 20 and a negative 6 is a negative 26. Negative 5 and negative 20 is a negative 25. Go ahead now, pause the video, see if you can try to do the 6a minus 3b on your own. Take a minute to do that. Once you've completed it, go ahead and hit play. I'll work out the solution. You can see if you're right or not. So once we work this out again, we're going to have 6 times a. So we have 4, -2, 5, and -9. Minus 3 times b, which is 8, 2, -1, and -3. Distribution first, so 6 times 4 is 24. 6 times -2 is a -12. 6 times 5 is 30. And 6 times -9 is a -54. Again, I multiplied by the -3, and that turned into an addition problem. -3 times 8 is a -24. -3 times 2 is a -6. -3 times -1 is a +3. And then -3 times -3 is a +9. Now, as long as your dimensions are both the same, you can add them. They are indeed the same, so we have 24 and -24 is going to be a 0. -12 and a -6 is a -18. 30 and 3 is a +33. -54 and 9 is a -45. And that would be your solution matrix. So double check your answers, see if you got the same thing as mine. If not, go ahead and pause the video, see where you went wrong, go ahead and follow through with my steps, and see where you might have gone wrong. Here we have example number 5, where he says the table below shows the number of endangered and threatened species in the United States and in the world. How many more endangered and threatened species are there in the world than in the United States? So really what we can do is we can create 2 different matrices here. We can create one for the United States and then one for the world. So really this is one matrix. That you can create. The first column for the endangered, the second column for the threatened, and then each row represents the mammals, the birds, the reptiles, the amphibians, and the fish. And then we can have a second matrix over here of all of this information. Now if we're looking at how many more endangered and threatened species are there in the world, the United States, what we're going to want to do is take the matrix that has the world and subtract the one that has the United States. So when we do this, I'm really just going to kind of flip-flop these. We're going to end up having 319, 27, 252, 19, 78, 37, 19, 11, 82, and 44. Then we'll bring the United States over to this side, so we'll have 68, we'll have 10, we'll have 77, 13, 14, 22, 11, 10, 71, and 43. And we're going to do subtraction in between there. So now here's the problem we're doing. We have the first matrix minus the second matrix. And when I do that subtraction, we're going to have 319 minus 68. 27 minus 10, 252 minus 77, so on and so forth. So go ahead and complete that problem now. So for that first one, we should get 251. The next one we have 27 minus 10, which is 17. 252 minus 77 is 175. 19 minus 13 is 6. 78 minus 14 is 64. 37 minus 22 is 15. 19 minus 11 is 8. 11 minus 10 is 1. 82 minus 71 is 11. And then 44 minus 43 is 1. Again, making sure that the final matrix we end up with is the same dimensions as the first two matrices we had, which would have been a 5 by 2. So there's 5 rows, 2 columns. Here's the homework that you'll be doing in class tomorrow. This is going to be on page 173. 14 through 24, all of them, and then 25 through 35 odds. If you want to start the homework, feel free. Again, you will have time to do that in class tomorrow because we're almost treating our in-class time now as some individual practice time where you can ask me some questions on the lesson. We can review some of those things in the lesson, but then you can also have time to work on this and ask me questions that you come up with as you work on that. So again, don't forget to bring this to class. Bring the note sheet because that is your homework, so I will be checking that to make sure you have that done. That's where you're going to be getting your homework credit now, is with those note sheets, not necessarily with this homework. So you'll be getting a grade for this, but you'll also be getting a grade for those notebook sheets, or the note sheets that you'll be completing at home with this video. Alright, I will see you guys tomorrow in class.